everyone, I hope all of you are doing good, and today I am back with a video on class 6 science, motion and measurement of distance. We come across a lot of situations in our day-to-day life where we measure distance. Agree? No? Let's think of such situations. Let's say I want to get a cloth stitched. So I go to the shop to buy cloth. Now the shopkeeper asks me, how much cloth do you need? So I need to tell him whether I need 5 meter, 2 meter, 1 meter cloth. So how much do I need? Right? So what am I trying to do? I'm trying to measure the length of the cloth. If I ask you, what's the size of this room? Now you may say, the room is very big. Okay, that's fine. But that's not the exact size of the room. So in order to tell the exact size of the room, you need to measure the length and the breadth of the room. Right? You go for morning walk every day. Now if I ask you, how much distance did you cover today? You may say, I took 10 rounds of the park. Now again, that's fine. But how much total distance did you cover? You visited the market yesterday and you drove your car. So how much distance did you cover? So you see, in all of these examples, what are we trying to do? What are we trying to measure? We are trying to measure the distance covered. So what we understand is measuring distance is something that we do in our day-to-day life. So let us try to understand distance better, and also how do we measure distance?
How do we define distance? It is the total path length an object travels from initial to final position. So let's take an example in order to understand it better. So let's say this is your home and this is your school, and this girl is traveling with her bicycle from home to school. Okay, so what would be the total distance here? So in this case, the path length from initial to final position. So what is the initial position? Home is the initial position, and final position is the final destination, that is school. So that means the total path length that she is going to cover from home to school, that path length is nothing but the distance, right? So as she moves, she is actually covering the length of the path. So by the time she reaches school, she has covered the distance between home and school. Now the question is, how do we measure this distance? Now we want to measure the distance, that how much distance she has covered. So for that purpose, we need a parameter. Like, let's say, how do we know whether the distance between home and school is more, or the distance between home and the market is more? So we need some parameter, we need some figures which will help us to determine the precise length or the precise distance. So there we introduce the concept of units. So units help us to measure anything. So let us try to understand what are units. These are internationally accepted reference standard to measure a physical quantity. So what is a physical quantity before that? So anything like distance, speed, weight, mass, these are all different physical quantities, right? So here we are primarily talking about the quantity length or distance. So in order to measure the distance, we need some reference, and that reference has to be internationally accepted so that the same reference holds true in different parts of the world. So these type of reference standards which are used to measure physical quantities are called units. So let me give you some example. Let's say you are sent to the market to buy potatoes, milk and rice. Okay, so now how will you tell the shopkeeper how much potatoes or how much milk or how much rice do you want? So you need to specify, right? There might be a huge amount of potatoes stocked in the shop, but you do not want all of them. So how much do you want? So when we talk about potatoes, let's say that, okay, it is still possible to define the amount of potatoes in numbers. Let's say you went to the shopkeeper and you told him that I want 4 potatoes. Okay, we still agree to it that you can count the number of potatoes and ask for it. What would you do with rice? Do you think that it is possible to count the grains of the rice? Will you be able to tell the shopkeeper how many grains of rice you need? No. Will you be able to count milk? How much milk do you want? You do not have pieces, you do not have grains. So it is not possible to count. So rice or milk, these are not countable quantities. So therefore, we denote the quantity of each of these in terms of units. For example, you would say the shopkeeper, I need 5 kg potatoes. I need 1 kg rice. I need 1 liter milk. So what is this kg? Kg is nothing but kilogram, liter, kilogram, liters. These are all units which are used to define or which are used to measure specific quantities. For example, liter is used to measure volume. Kilogram is used to measure mass. So that means there exist different units for different physical quantities. Now, why is it important that these units should be internationally accepted? That's because, let's say today you are in India. So in India, when you are going to buy milk, you are saying that, okay, I need 2 liters of milk. Okay. What if you go to Europe? So there also you want to buy milk. So there also they should be able to understand how much 1 liter means. So therefore, liter has to be an internationally accepted unit so that people throughout the world know how much 1 liter is. So that is why it is important that units are internationally accepted reference standards. So that 10 kg rice should mean the same quantity in India, US, Europe and everywhere throughout the world. So when you say the shopkeeper that I need 5 kg of potatoes, what he does, he puts the potatoes in his weighing balance and then he measures 5 kgs of it and then give it to you. So that's like a simple process. Now the question is, since we have been talking about distance since quite some time, and distance is all about length. So when we talk about distance, we are basically talking about the length of the path that is being covered. So how do we measure length? What are the units for length? So the SI unit for length is meter. Now what is SI unit? So SI stands for System International. So now there are several units which exist for each physical quantity. Now there are many traditional units which are different in different parts of the world. So therefore, for every physical quantities, a specific unit has been declared as the SI unit, that is the internationally accepted unit, which will be understood everywhere in the world. Now, there are many other units for length. For example, if you go to small towns and villages in India also, you will see that a lot of people measure length in terms of the width of their fingers. A lot of them measure length in terms of the length of their forearm. So that's how different people also use different references to measure length. But the standardized and internationally accepted unit is meters. Other units also exist like kilometers, decimeter, centimeter, millimeter, but meter is the standard one. So now when you have to stitch a cloth, so how do you know how much of cloth you need? So you will measure how many meters of cloth you need. Maybe 2 meters should be sufficient for a dress. So you just tell the shopkeeper, I need 2 meters of this cloth, and that's how you do the purchasing. And that's how you precisely know how much cloth is needed for a dress to get stitched for you. So now when we talk about units, as I was telling that every physical quantity needs some unit to get measured. But when we compare the number of units with the number of physical quantities, we see that number of units is comparatively lesser than the number of physical quantities. So if there are 10 physical quantities, there exists less than 10 units for those physical quantities. What does that mean? That means that it is not necessary that for every physical quantity we should have a unique new unit. So many a times it happens that 2 or more existing units combine together to form a unit of some other physical quantity. So let me give you some examples. Let us talk about 2 physical quantities. One is energy and the other is work. So work and energy are two different physical quantities. Okay, but when you look at the units of work and energy, both of their SI units is joule. So for work also the SI unit is joule, and for energy also the SI unit is joule. So these are two different physical quantities, but they have the same unit, right? Similarly, let us talk about this example. Let's say you have this room. So what would be the unit which is used to measure the dimension of the room, maybe the length or the width of the room? How do we measure? We would measure it in meters, right? Now, if we talk about a car which is moving, so this car has a certain speed with which it is moving. So speed is another physical quantity. Now what is the unit for speed? It is meter per second. So what is meter? Meter is the unit for length, and what is second? Second is the unit for time. So basically meter and seconds are two existing units for two different physical quantities, and they have been combined together to form unit of a new physical quantity. Again, you talk about area of this room. If I ask you to find the area of the room, so the area would be the length, unit for length is meter. If you ask the unit for area, that would be meter square. If you ask unit for volume, that would be meter cube. So you see these meter square, meter cube, these are new units, but these are derived from the basic unit, that is meter. Right? So this meter square, meter cube are derived from the existing unit meter. So these type of units, the unique units, these are called basic units, whereas the units which are derived from the basic units, they are called the derived units. So basic units, or you can also call them as fundamental units. Now the number of basic or fundamental units are very less. So around 7 fundamental units exist. All other units are derived from these fundamental units. Now looking at all these examples, you can understand that why the number of units are lesser than the number of physical quantities. Now please do not bother yourself with these terms like speed, energy and work, because these are different physical quantities about which you will learn in your higher classes. Right? So this slide was just to give you an idea that the number, if there are 10 physical quantities existing, then the number of units would always be less than 10. Okay, so now again let us get back to the measurement of length. Now I said that meter is the SI unit for length, but besides meter there are many other units also for length. So let us look at the various units of length. So they are millimeter, centimeter, decimeter, meter, decameter, hectometer and kilometer. So these are the different units to measure length. Now you might say that why do we have so many units to measure the same thing? So I'll just explain that in the next slide. But for now you just need to understand that you have to remember this sequence. So one easy way of remembering it is millicentideci, and then you have decahectokilo. So meter is at the center. So on the top you have millicentideci and at the bottom you have decahectokilo. So that is one easier way when you shorten the names, so it becomes easier to remember the sequence. Now why you need to remember the sequence is this unit, that is millimeter. So this in short it is written as mm, this is written as centimeter, that is cm, this is decimeter, that is dm, meter is written as m, decameter is written as dam, because decameter or decimeter otherwise would be confusing. Hectometer is written as hm and kilometer is written as km. Now if you look at these units, you would see that millimeter is the smallest unit and kilometer is the biggest unit. So basically as you move down, the units represent more quantity. So that's how, like centimeter is a bigger unit than millimeter, decimeter is a bigger unit than centimeter, and so on. So that's why it is very important to remember this sequence. So now the most important question, why so many units? Now let's think of a certain situations. So let's talk about two different cities, let's say Chennai and Bangalore. These are two different cities, and how much is the distance between Chennai and Bangalore? Any idea? Okay, even if you don't have, I will tell you. So the distance between Chennai and Bangalore is not very less. They are like quite far from each other. So the distance between them is approximately, let's say, 350 kilometers. Now, since the distance here is very huge, we need a bigger unit to express it easily. So, since we have expressed it in kilometer being a bigger unit is used to measure long distances. So distance between two cities, distance between two countries, so they are expressed in bigger units. Now kilometer is not the biggest unit, but among the units which we have discussed, kilometer is the biggest. Now let's talk about another example. Let's talk about a plastic pipe. So the water pipe which looks somewhat like this. Now if I ask you the thickness of this water pipe, so the thickness would basically be determined by the diameter of the pipe. So let's say this is the mouth of the pipe, and so basically how much is this? We basically want to measure this length. Now looking at this pipe, you can understand that this length is going to be something which is extremely small. It is a very small distance or a very small length. So in such cases, we often measure it in millimeters. Let's say we say that it is a 12 millimeter thick water pipe. So what is this millimeter? So it is a small unit. So when it comes to measurement of length, sometimes we need to measure lengths which are like large in value, so we prefer to use bigger units. Sometimes we are measuring lengths which are very small in value, so there we prefer to use smaller units. So that is why we have a variety of units, so that they can be used in different situations as needed. Let's again take another example. When you talk about your height, when you measure your height, so one common unit that we often use is feet, but when you look at the units which I have discussed just now, centimeter is a very common thing which you use to measure height. You say his height is 176 centimeters, his height is 180 centimeters, and so on. When you measure the length of the cloth, you often refer it in meters, because the length of the cloth which you do not go to the shop and say I need 5 kilometers of cloth, because you really mostly you do not need so much of cloth. So the unit which is normally used, that would be used here, is meter. So based upon how much length are you measuring, the respective unit can be used. So now one beautiful thing is that all these units are interconvertible. So you can convert meters into kilometers, you can convert centimeters into decimeters. So you can actually convert any of these into another other unit. So let us look at the relationship between all these units. So as I said, this is the smallest unit and this is the biggest unit, and we consider the reference as meter. So 1 meter is our reference. Now as you go down, these becomes bigger units. So basically when you talk about decameter, so 1 decameter is actually equivalent to 10 meters. 1 hectometer is equivalent to 100 meters. 1 kilometer is same as 1000 meters. Now similarly, as you go above, that they become smaller than meter. So 1 decimeter would become 0.1 meter. 1 centimeter would become 0.01 meter. 1 millimeter would become 0.001 meter. So as you are going up, the value is decreasing. As you are going down, the value is increasing because the unit is more. So if you consider it on a scale like this, so let's say if this is 1 meter, just an example, it is not really 1 meter, I am just taking an example. So if you assume that this much length is 1 meter, so can you tell me how much would be 1 millimeter? So 1 millimeter is actually equal to 0.001 meter. So that means 0.001 part of 1 meter. So 1 millimeter would be maybe this much distance. A very small distance would be 1 millimeter. And if I ask you how much would be 1 kilometer, that is going to be 1000 times of 1 meter. So if this is 1 meter, 1,000 times such 1 meters would make 1 kilometer. So 1 meter, when you multiply this 1,000 times, so 1,000 such 1 meters would make 1 kilometer. So with this you can get an idea that how these units are related to each other. So now let me again take the same example of need for so many units. So as I was telling that when we want to measure bigger distances, we prefer using bigger units. Do you know why? Now let's talk about the same example of Bangalore to Chennai. So I said the distance between Bangalore and Chennai is 350 kilometers. Now writing 350 kilometer is very convenient and it is very easy to remember also. So it is a very easy way of representing when we are representing in terms of kilometer. So if you try to write the same distance in meters, how would you write? Now 1 kilometer is equal to 1,000 meters, right? So 350 kilometers would be equal to 350 into 1,000 meters. So that would be 350,000 meters. Now you tell me which is more convenient. Is it convenient to write 350 kilometer or 350,000 meters? Obviously, this is more convenient. If you want, you can also write this in terms of millimeter. So how would you write it? If you write the same thing in terms of millimeter. So millimeter would mean 350,000,000. So that's how the number would increase. Number of zeros would increase, which will make it all the more inconvenient. So the most convenient way of representing a bigger distance is by using bigger units. Similarly, when we have to represent smaller distances, we would use the smaller units like millimeters and centimeters. Right? Now, a lot of times you might need to convert from one unit to another. So one simple thing, if you remember, that would help you to convert a measurement from one unit to another. And that is, whenever you have to convert from a unit from the bottom towards the top. So if you want to say convert kilometers to decameter or kilometer to meter or decameter to decimeter, so everywhere you are actually going from bottom to up. So from a unit which is at the bottom to a unit which is at the top. So whenever you are doing that, you are going to multiply. Multiply with what? Multiply with multiples of 10. Let me explain you. Let's say you have to convert kilometer to hectometer. So what you do? You will multiply with 10. If you have to do it for kilometer to decameter, so you multiply by 100. When you have to do it for kilometer to decimeter, so how many steps? 1, 2, 3, 4. So basically you should have 4 zeros. So you multiply with 10,000. If you want to convert kilometer to centimeter, so one more zero. So whenever you are converting from one unit which is at the bottom to another unit which is at the top, you always multiply by multiples of 10, and how many zeros would be there depends upon the number of steps between those two units. And exactly the same concept when you are converting from one unit which is at the top to one unit which is at the bottom. So let's say when you are coming from top to bottom, all you need to do is you divide by 1 multiples of 10. For example, you have to convert centimeter to decimeter. So you are coming from top to down and it is just one step. So you divide by 10. You want to convert centimeter to decameter. So here you are coming from top to bottom. So you have to divide. And how many steps? 1, 2, 3. So you have to divide by 1000. You have to convert from centimeters to hectometers. Again, you are coming from top to down, and how many steps? 1, 2, 3, 4. So you have to divide by 1 followed by 4 zeros. That is 1 followed by, that is 10,000. You have to divide by 10,000. So this is how you have to convert from one unit to another. So always remember, when you are going from down to up, you have to multiply, and when you are coming from top to bottom, you have to divide. So that's how it is. So now, as I was telling that there were certain traditional units which were normally used before, and in fact today also we use it in certain parts of the country to measure distance. So let's look at what were those traditional units. So some common units were foot, and people used the length of the foot as a reference, that is this length of the foot as a reference to measure distance. So let's say they have to measure the say length of the room. So what they would do, they would just step there and they will measure with their own foot, and let's say it is like 10 foot. So they will say that okay, the length is 10 feet. So that's how they would measure. So foot length was one very common traditional unit. In fact, today also we often tell our height in feet, like he is 6 feet tall, she is 5 feet tall. So that is also the same foot which we are referring to. Another traditional unit is cubit. What is cubit? So cubit is the length of the forearm. This is the length of the forearm. So cubit is the length of the forearm. Now, have you ever seen anyone using cubit as a unit for measuring length? So one common thing which you would have seen is in many small towns or villages, even big cities, a lot of women who sell flowers, especially the garland of flowers, the white garland of flowers, the orange garland of flowers. So if you ask them what is the price for the garland, so they generally tell you the price per cubit. That is, they will measure that garland like this as per the length of their forearm, and they will charge you maybe 30 rupees for 1 cubit. So that's how they still measure the length of garland. So that was another traditional unit. Another was the width of the fingers. So when you say width of the finger, this width of the finger defines how much is the length. Tailors often use this unit to decide how to make proper fitting of your clothes. So if you have ever visited a tailor to say that okay, my dress is very tight to me, so just loosen it. So how would he measure? Many a times they do it like this. So if they'll keep one finger and they'll say okay, I'll loosen it by this much length. Sometimes when they put all the 3 fingers, so the length would increase, it would become this much. When they open all the 4 fingers, the length would be this much. So basically the width of the fingers are used to measure the length. So these were some traditional units where different parts of the body were used as reference to measure the distance. However, this using of traditional units has a lot of disadvantages associated with them. So the most common disadvantage was that there is no uniformity in size. Now when you are using your foot, or you are using your hand, or you are using your fingers or forearm as a reference, now different individual will have different size of their arm, different size of their fingers, different size of their foot. So everything is not universal. The size of the foot of a child would vary from the foot of an adult. Again, for all adults also the size is not same. Some people have like smaller foot, some people have bigger foot, and that is why the sizes of your shoes also change. Right? So that means you are actually not referring to something which is of standard size. So let's say I told that okay, I need let's say I said that I need 3 cubits of a garland. Now the person who measured it, maybe that person's forearm length is very small. So that means the amount which you would give me would turn out to be less for me, because my cubit length is more, the length of my forearm is more. So that means it creates a lot of confusion, and basically in this case we are not able to measure the distance precisely. So we are doing incorrect measurements. So that is why using traditional units are not preferred. So the question is, how do we ensure that we have measured length correctly? So that is why in order to measure length correctly, the first thing that is preferred is a measuring scale. So if we are measuring length of objects which are like straight objects, so we prefer a measuring scale. So a few things that need to be remembered while taking the measurements are as follows. So let's say you want to measure the length of this table. So you have a meter scale like this. So with this you want to measure the length of the table. So the first thing that should be remembered is the scale should be in contact with the object. Let's say you want to measure this length and you are keeping the scale here. So that will not work, because that will again not give you a precise measurement. Maybe you will be taking a wrong measurement. So it is very important that you put the scale at the right position. So this would be the right position for the scale. The scale should be in contact with the object. So this is our object and this is the scale. So both should be in contact with each other. The next important thing is measurement should be taken from 0 mark. So when you observe a scale, very precisely, you will see that there are markings on the scale like 0, 1, 2, 3, 4 and so on. So it is very important that you start taking the measurement from the 0 mark. So as you can see here, the scale has been placed in such a way that the length actually starts from 2. So if you measure it this way, you will end up taking a wrong measurement. So it is always important that you start measuring from 0. So instead of this, the scale should be placed like this so that the 0 starts from here. So correct placement of the 0 mark is very important. The third point is eye should be exactly in front of the point where measurement is taken, because we are seeing that measurement with our eye. So the placement of the eye is also important. Now you should not sit far away from here and then from there try to observe the measurement. So that is absolutely not correct. You should also not be at a height which is lower than that of the measuring scale. So where the measurement is happening, your eyes should be at the same level as that of the object. So this is also not the right way. So yes, this is the right way, where your eyes are at the same level where the measurement is being taken. So these are some of the points which need to be remembered while you are taking measurements, so that you are able to measure it correctly. Now many times it happens that the scale is broken from one end. So if the scale is broken from here, then it might become difficult to start the measurement from the 0 mark. Maybe the 0 mark portion is broken. So in that case, if you are starting from 1 here or say 2 here, then whatever measurement you get here, so you have to compensate this from that side. So let's say you have started from 2 and here the measurement comes out to be whatever 29 or 30. So you actually need to subtract those 2 centimeters from the measurement which you actually read on the scale to compensate for this extra thing which you had because the scale was broken. So that consideration need to be done in order to get a precise measurement of the length. Now there are many devices which are available to measure length. Now some of the common ones are meter scale, the measuring tape. Now in a lot of cases you need something which is flexible to measure length of objects which are curved, because scale cannot be used to measure length of objects which are curved. So in those situations we make use of the measuring tape, which is almost like a thread, and then in fact the tailors often use this to measure the waist length, to measure the length of your arm and shoulders and etc. So this is like a ribbon, so it is more flexible, but at the same time it also the ways to measure remains the same as that of the meter scale. Now when you talk about range of lengths, now we mostly talked about the units which we discussed from millimeter to kilometer, but sometimes there are certain special units which help us to measure distances which are extremely large, or to measure lengths which are extremely small. Now there are certain special units for these. So let us look at some of these special units. Now sometimes we want to measure lengths which are extremely small. Extremely small means, let's talk about the size of the atoms, the size of the nuclei. So when we go to that level, now since at this level you might not be knowing what is an atom or what is a nuclei, I'll just give you a brief introduction to it. So anything that we see around us is all matter. Any object that we see, a glass, table, chair, we are ourselves, all matter. So these matters are made up of small molecules, and the molecules are made up of small atoms. So these atoms are like extremely tiny. They are so tiny that we cannot see them with our naked eye. In fact, we really need powerful microscopes to actually see them. So they are that small. So when you have to measure lengths which are so small, in that case again we need some very small units which will help to represent them easily. So some such very small units are Fermi and angstrom. Now let's look at their relationship with meter. That will help you to understand how small are these units. So 1 Fermi is equal to 10 to the power minus 15 meters. So you know what is 10 to the power minus 15? It is like 0.000000000. So you actually have 15 zeros and then 1. So it is that small. So that much small part of 1 meter. So that's 1 Fermi. Similarly, 1 angstrom is equal to 10 to the power minus 10 meters. So again, these are like extremely small units. So when you want to, these are therefore termed as special units. Now we will not deal with these special units as of now. So just for your information, I am telling you the range of length is like quite huge. We have lengths which are very, very small. We have lengths which are very, very large. So let's look at the other extreme end. There are certain lengths which are extremely large. For example, when you talk about the distance between two planets, when you talk about the distance between the sun and the earth, so these kind of distances are like extremely huge. So kilometer is again a very tiny unit when you talk about such huge distances. So here you have bigger units like astronomical unit and light year. These are units of distances which are often used for huge distance. So 1 astronomical unit is the distance between the sun and the earth, and it is 1.5 into 10 to the power 11 meters. So that much is the distance. And 1 light year is the distance that light travels in 1 year. So that's going to be a huge distance, right? And that is 9 into 10 to the power 15 meters. So these are all huge lengths. So this was just a special slide to let you know that sometimes the lengths could be very small or it could be very large, and for that purposes we have certain special units to take.
I hope you found this video useful. Like the video, share the video, and do let us know your feedback in the comment section. In the next video, we are going to learn about motion. So be with us.